Hello, and welcome to this fourth video in our series on how to create an animated game with Dolphin Smalltalk. I'm hoping by the end of this session we should be able to have a fully working game which is actually playable. And if you remember, at the end of the last video we created our game shell window. We had the ability to initiate a flight from one city to another, from London to Paris, using a menu command. And the only thing that was missing in that section was the ability to detect that the plane had arrived at its destination city. So that's our next task, and let's move on. Now, if you remember, when we were designing our ATC plane class, we added a method called update for time interval in model, and we used this to in part to detect whether there was a collision with another plane inside the model, and if so, we'd destroy the planes. So what I want to do here is I want to add another test in here to see if our plane's actually arrived at its destination city. So let's add that here, call it arrival detect in model. Okay, and if we compile that and let it run, we notice that it's not implemented, so let's implement that inside ATC plane. And what we're going to do here is we're going to subtract the current location of the plane from the destination city's location and see if the magnitude of that vector is less than the radius of the city, which will mean we're inside the city circle. So we'll take our position, convert it to a 2D point rather than the 3D point to ignore the height, and we'll subtract the destination city city's location, and then we will compare that with the destination city's radius. Okay, now if that is less than, if that's true, we can then remove our plane ourselves from the model, and that will remove us from the simulation. I want to do one other thing here. I want to also trigger an event when we've arrived at the city, and we can use that later to bump our score in a positive direction if a plane has succeeded to arrive. So what I'm going to do is here, I'm going to trigger an event, and let's call that event arrival of, and we'll pass a plane at a city. So we'll pass ourselves over and the destination city. Okay, now I've just noticed something here in the debugger, that our destination city currently seems to be set to a plane and not a city. So we've got a little bit of an error there. So what I'm going to do is I'm going to compile this method, and then I'm going to just come out of the debugger here, and let's delete this and try and see where we've gone wrong there. Obviously, when we were creating our new plane, we passed over the wrong thing. So destination and departure will probably be right. Yeah, so it's most likely in our constructor for plane. Yeah. Destination city, we passed over the wrong thing here. This should be destination. Okay, so now let's try this again. Let's create ourselves a new game shell. Show it. Okay, the flight's going. And you notice over here in the list we actually have the plane entered. And it's got in there, and it's the arrival has been detected and the plane has been removed. Let's do that again. So good. And once again, as I say, we have the plane here, but we don't have any great information written into these columns. So that perhaps is our next task, to actually populate these columns correctly inside the view. So let's go back to the view composer to do that and see how we might do that. I'm going to close this view and go to the view composer to edit the game shell. Now, to populate these list box columns correctly is fairly straightforward. What we need to do is to find the list view that we have inside this main game area, and to go to the, if I just resize this slightly so we can see it a bit easier, go to the columns list and choose the various columns, and for each one define a get contents block, which will say what we want the contents of the column to contain. Now, the get contents block is passed over a parameter, which is the item being displayed by the list. In this case, the parameter is an HEC plane. So they're being passed over a plane, and we want to display the flight ID. Okay, and remember this is a block, so you must include the square brackets. I can file that. Now, there are some other methods here, which, or some other properties here you can also define. You can define the image block for that column, and you can also define the text block. The text block basically is passed the result of this block, so it will be passed over the flight ID, and the default version of the getTextBlock actually uses display string to display the text. We don't need to change that. So, and indeed we won't need to change that in any of the cases we're dealing with right now. So let's go to the departure destination and define the get contents block. Similarly, it's passed over the same plane, and this is the departure city. Okay, and similarly with the third column, we're going to fill the get contents block with the destination city. I'll compile that, and now let us save this out again, this view out again. Let's go back to our working window. Let's just check that we've actually got departure city and destination city defined. We actually have destination city defined, but not departure city, so let's do that now. Let's create an accessor for this. And while we're here, I'm just going to do, before we actually go back and test this, I'm just going to change a few more things to speed us on our way. If you remember, we in this update for time interval in model, we did this collision detect. Now, some time ago, you may remember that when we had a collision between two planes, only one of them got destroyed. Now we need to fix this because both planes need to get destroyed now. And also, we need to trigger an event for planes colliding so that we can decrement the score. Obviously, planes crashing is a bad thing. So let's actually go and look at the collision detect in model method and make some changes to this. One thing we need to do is we need to work out what the closest plane is when we're running this method, so we're going to need to add another parameter here. So here we need to, instead of just doing this minimum test here, what we need to do is we need to say, is the distance less than the current minimum? And if it is, we remember the closest plane, and we answer that distance from this block, this inject block. In which case then we don't need to actually have this current min part here, but we do need to have the alternate case here which answers the existing current minimum. Okay, that should do it. Now when we come down to here, we need to, instead of just destroying the one plane, we need to also destroy the closest plane as well. And as I said before, what I'd like to do is also trigger an event off the model to indicate that two planes have been destroyed. So let's trigger a two-parameter event with, let's call the event planes destroyed. Actually, let's make it a one-parameter event and pass over an array of planes. Planes destroyed, and we'll have an array with self and with the closest plane. Okay, that should do what we want. Now, back over in the shell view, let's hang on to these events and do some sensible stuff with them. So we've been creating our components here, and when we assign the after the components have been created, the model is assigned. Now here, let's hang off the events that the model triggers and make them call some methods inside the game shell. So let's look for when a particular event is triggered off this model. So when the arrival of event is triggered, when the arrival event is triggered, we want to send a message to ourselves. Let's call it onPlaneArrived. In fact, we can ignore the parameters that go with that event, because we perhaps don't need them. Okay, and similarly, when the plane destroyed event is triggered off that model, we can send once again a no parameter on planes, and no parameter message on planes destroyed to ourselves. Now in those methods we can do some stuff to bump or decrement the score. So let's implement those methods now. So we want on planes destroyed, and what we can do with this is assign the score to be equal to the current score minus some sort of decrement factor for each plane that's been destroyed. So let's make a method for that. Planes destroyed score. Okay. Now, this on planes destroyed event is triggered on inside the update process that is running in the game loop. So the problem will be with this is that the self-score method will actually want to modify the score that we see on the screen, which is actually a component that normally is modified by the user interface loop, or the user interface process. So really we need to synchronize these two operations. Now there's two ways to do that. The first way would be to use a mutex and to make sure that the user interface process and the game update process are synchronized so that two things don't collide. But another way to do this is to actually, inside the update loop processing, i.e. this onPlaying destroyed method, we can actually create a block and we can post this to the input queue. So this then gets synchronized with the main Windows processing message loop. And this is quite a convenient way of synchronizing any background processes with the main user interface process. And the way we do this is to take a block and say post to input queue. Okay, that's quite a convenient way of synchronizing these things. Now obviously we haven't got these score methods defined as yet, so we can do that as well. Let's add a private method. Let's do some of these awesome privates here. Okay, that's private. That's private. And we'll leave the commands as public. But let's also let's just define the onPlaying arrive method. And in this case, we're going to make that actually add to the score the playing arrived score. Okay, once again, we're going to use the trick of posting this block to the input queue to synchronize it with the UI process. And I think now would be a suitable time to actually try this out. Let's just save the image and let's start the view. Okay, now let's create a flight, London to Paris. Oh, we've got not quite got the correct thing there. ATC Game Shell does not understand score, so let's implement that. Okay, now we created a score presenter to show the score in the window. And this will have a value, so the score is actually the score presenter value. The score presenter was a value presenter, so it responds to the value message. And also we need to define an incremental score for whenever a plane arrives. Plane arrive score, let's make that say 200 and let that run. Similarly, we need to have a method to set the score. Okay, so I've got the new score. So what we're going to do is we're going to set that value into the score presenter. And let's let that run. So as you see, we've actually incremented our score there. Let's run that again. And there you see our score gets bumped. Now there was something wrong here. We didn't actually have the correct details being displayed here. Okay. So we need to just check that, and I know what's wrong here. What we need to do is we need to implement display on inside the city, the ATC City class. So inside ATC City, I think what we basically need to do is to create a display on method. And really we can just want to display the name on the screen. Okay, and if we go back to our simulator, that's better. We now have flight AF126, departure London, destination Paris. Great, and we should be able to send another plane after it. And because these two planes are close together, we now got the collision warning with the different colours. And if they actually were to collide, we might see that the plane destroyed score gets triggered. Let's implement that. And let's make that also 200. Let's have that away. Okay, so that's basically the fundamental parts of the game working. The next thing to do will be to just allow us to select the planes and steer them. Now, if you remember when we created the default view for our ATC game shell, we included a couple of menu commands, turn left and turn right, which are intended to be received by the game shell presenter and then forwarded to the currently selected plane to allow the user to steer the planes to avoid collisions. So let's go and implement this feature now. First of all, let's go to ATC plane, and we can implement turn left and turn right in ATC plane to turn the plane left and right. I think the best thing to do would be to have a rate of turn instance variable which keeps a tally of the current turning rate of the plane. That means we can basically use turn left to increase the turn rate and to the left, and turn right to increase the turn rate to the right. So let's create a rate of turn instance variable inside our ATC plane. Okay, oops, spelled that wrong. Okay, and now let's go and initialize that to 0 when we first create our plane. Let's do that inside the initialization method flight ID colon. So let's set rate of turn here equal to 0. Let's create an accessor method for rate of turn. Accessors. Okay, and now let's in here implement our turn left and turn right commands. So let's create turn left. Okay, so what we want here is for our rate of turn instance variable to be bumped down by a certain amount. We'll say turning is positive clockwise. So we'll decrease the rate of turn by some set amount, which we can put into a parameterizing method. Turn amount. Okay, and similarly turn right can just increase that. Let's define our turn amount method. To answer, let's say, 10 degrees. Okay. Now what we need to do is to arrange for these turn left and turn right commands to be forwarded to the currently selected plane in the ATC game shell. So if we go back to ATC game shell, and we will, if you notice at the moment with our running game, we don't have these turn left and turn right commands enabled. That's good because we haven't implemented those methods inside the presenter class. So let's do that now. Let's go and implement turn left, and we'll implement that as finding out what the currently selected plane is. So we'll create a method in a minute called selection or nil, which will answer the plane or nil if there is no selection, and we'll pass that turn left. Yep. And similarly, let's implement turn right at the same time to do the same thing. Now, once we are we have the planes turning left and right, what we need to do is we need to make sure that that gets actioned inside the ATC plane update loop. So let's go and look for the update method inside ATC plane. And what we need now is we need to compute a new heading. And we will do this with simple calculation. Let's get the current heading. And we will add the rate of turn times the time interval times some sort of scaling factor. Okay. So I've done that wrong there. Okay, and now we need to set that new heading back into the set that as the heading of the plane. Using heading colon speed. Oops. Okay, now some of these methods are not yet implemented. Self-heading is not yet implemented and self-speed is not yet implemented, so let's go and do those. And we're going to need to do a little bit of geometry here. Okay, so here's the completed heading method. A bit of trigonometry there. We can now move on and implement our speed method, and this simply is the 2D velocity vector. And then we'll send the message R to it to get the length of it. Okay, now one other thing we need to do is to go to the game shell and to implement selection or nil. This needs to answer the currently selected plane, and that can be derived from the selection in the planes list presenter. And sending selection or nil to that. Okay, so now let's save our image, and let's go and find our game and set a plane flying. Actually, before we do this, let's just go and slow things down in the plane model, because otherwise I think it would move a bit too quickly off the screen. Let's slow this down by 10 times. Well, I can see a mistake here. This should be 0. There we go. Okay, so let's go back to our game window and set a plane flight from London to Paris. Let's select that and choose turn left. And as you can see with that, it's just slightly altering the angle of the flight. Let's slow the plane down again. Let's make that go a third of the speed again. Let's go back and try that again. So if we now choose a plane from London to Paris, that's going a lot slower now. If I now select that plane, and we can use turn left, and I think you can probably see that as we keep turning it left, it starts to steer left. And I can indeed use the control keys. I'm typing Control R now to slow that turn down. So now we're heading that way. Let's do a couple more Control R's to get the rate of turn heading up. And so that's how we can steer our plane on course. Let's get it back heading towards its target. And I can stop the rate of turn now with Control L. There we go. Okay, so now we have the ability to control the rate of turn both from the keyboard and from the menus. Obviously, when you're playing the game, you're going to want to use the keyboard because it'll be too slow to use the menus. But one thing we don't have is the ability to be able to select the plane using the mouse. Well, ideally, let's create another plane here. Ideally, we'd like to be able to click on these to make the selection here and here. So let's go and see how we might implement that. What we need to do is we need to go to the ATC view, and we need to intercept on left button pressed. Okay, and we want to check to see if the mouse event is inside any of the planes on the screen. If so, that will become our new selection. So let's say that selection is equal to, let's search through all of the model's planes. And try and detect whether the mouse event is inside their box. Each box contains point, that's meant to position, and if none, we'll answer nil, so that's selection. And now we can, let's trigger that as an event off the presenter. So presenter, we'll trigger plane clicked, colon, and we'll pass our selection across. Now obviously we're going to need to get something to hang off this event over on the presenter side, so we can do that in just a moment. But while we're here, the colon, sorry. While we're here, let us also just make a small modification to visual object at point. Currently we're only, if you remember, we used this to be able to use the visual inspector to be able to click on planes inside the ATC presenter. We might also want to be able to select cities using this method. So let's just modify this method slightly to actually include the cities in the list of objects to search. So let's also append, using the comma method, let's append cities to that. Okay, that's great. So now we should be able to click on the cities inside the game and bring up an inspector. So how do we actually hang off that that event in terms of detecting whether a plane has been clicked? What we need to do is we need to go to Game Shell, and the usual place to hang off events inside a presenter is to create schematic wiring method. Pass it to the superclass. Okay, and what we want to do is, with our airspace presenter, when a plane is being clicked, that event will be triggered off the airspace presenter, and we can redirect that as on plane, plane clicked to self. So what we should end up with is sending on plane clicked to our ATC game shell whenever a plane is clicked inside the game view. So let's try that now. Let's set a plane going. Let's click on that. Okay, that's not been entirely successful. Let's go out and see why that might be. Oh no, of course, sorry, we have to, because we've added this create schematic wiring method, we need to actually rebuild this view. So let's do that. So let's create a new game shell. Okay, and let's create a new flight and click on that flight. There we go. ATC game shell does not understand plane clicked. Let's go and implement that while the plane is moving. Okay, and what we need to do is we need to change the selection in the planes presenter using its selection or nil method, and we're going to select an ATC plane and we'll let that run. Okay, and now you notice that plane has become selected. Let's let that plane arrive at its destination. Let's create a new flight. Okay. And let's try that again. Create another new flight. Okay. Let's now click on this one and try and alter its course. Defined object does not understand turn right. Okay, what's happened? I know what's happened here. Basically, the planes have collided and disappeared, and we have been sending the turn right message to a nil selection. So what we need to do is we need to implement something that disables these turn left and turn right messages when in fact there are no planes. So the way we do that is with a query command message. What I usually like to do is go and steal one of those from somewhere else. So let's look for a query command. And we see there's a number of implementations of this. Let's choose one here. No, it's a bit too complicated. Let's choose this one. Okay, so let's drag that across into our game shell. Oops, excuse me. Okay, and modify that. Basically, what the query command message does is it says if it's a turn right command, we want to enable it, but only if we have a selection. That will work for turn left, and the same thing we can do for turn right as well. And now we should find that our selection, our turn left and turn right methods are only available in the menu if the selection is non-nil. So if we go back to, let's just tidy up these windows. If we go back to our simulation, let's set a plane going. Okay, and let's set another one going. Oops, that's automatic collided straight away. Let's wait till this has moved out of the zone. Let's let a new one go. We can select that plane, type Control R to try and turn it off course. There we go. And so basically this is the heart of the game now. You can see we can steer the planes to try and avoid collisions. Just redirect that to its target. Okay, during the break I've taken the opportunity to make a few quick modifications to the code we have, just to speed things up. Previously we'd only implemented the London to Paris command, but I've gone and implemented the other menu commands, London to Madrid, obviously just changing the destination city, London to Frankfurt, and London to Athens. These are just so we can test out some additional trial flights. but I've also implemented the command which was new random flight. Now, new random flight, the intention of this is to create a random flight between two randomly chosen cities. So what I've done here is basically chosen a departure city from the list of cities, and then from the list of cities with the departure city removed, I've chosen a destination city. Obviously we don't want the plane to fly from the departure city back to itself again. And then we just call the previous method that we've implemented new random flight from departure to destination. Okay, so that's a few more things we've added in there. Another thing I've done is to change the random number generator. Previously in our random method we just returned a new random, but this is not really very good in terms of its randomness. So what I've done is I've added a random instance variable, and in our random method I've initialized that using lazy initialization to a new random number generator if it hasn't already been set. That should provide us with much better randomization. One other thing I want to do, as part of the game, I want to be able to release a new random plane every few seconds. So in order to do that, I think the easiest way of doing that, we could start a new process to do it, but the most expedient way is to use a Windows timer. So I've added another instance variable which is a timer ID, and what we're going to do is we're going to create a timer when we start the game and destroy the game when we stop it. And in order to receive the timer events, we need to intercept in create schematic wiring. We need to intercept the timer tick event and use that to send a message to ourselves, in this particular case on timer tick, and I've implemented that here just to create a new random flight. So with all those changes done, let's just have a quick look to see how the game is running now. So let's create the game shell, show the game shell, and what I'm going to do is I'm going to increase the size of this so that we can see all the cities. Okay, and there we go. And what I'm going to do is to release a new random flight. One of the things I've done is I've increased the speed of the travel of the planes just to make it a bit quicker. I can now create another new random flight, as you can see, and so this is simulating how the game will run. It will create new random flights, and eventually we're obviously going to get two which are likely to run into each other. Let's keep going. Still nothing yet. Okay, now here we have a problem. So you want to select this plane and to try and turn it away from the other one, and then to turn it back again. Oh, that's unfortunately that was a collision. So anyway, basically you can see how the game works, and now the next stage is really just to add the game logic to detect when the game has been won or lost. I think what we'll do is we'll set a target score of 2000 for winning, and if the overall score goes below 0, we can call that a loss. So let's shut this down. So what we need to do is implement these two methods, start game and reset game. We'll shut this down and let's implement start game inside ATC game shell. First of all, when we do a start game, we might as well do a reset game first, make sure we're in a known state. Okay, and now this is where we create a timer, Windows timer, and we do this using the a view method, which is called set timer :interval. So we'll find our view, and we'll use set timer. Okay, we give it a timer ID. We're only going to be using one timer, so we can use a timer ID of 1, and let's assign that into our instance variable. And let's provide an interval which can be parameterized in a method, plain release interval. Okay, now I think we can do a bit of debugger coding again. Let's create our game shell. Okay, and let's execute start game. ATC shell game shell does not understand reset game. Let's implement that. The first thing here we should do is, if we're already running, we want to stop the game. Now we want to reset the model to be a new airspace. We're resetting the game. We can reset it to be our default model. Reset our score. And also, well, that should do it for a moment. Let's compile that and let it run. Let's implement stop game. Okay. Best thing to do here is, if we have moving planes in the game, let's just tell them to stop. So we can do that by iterating through the planes. Remember, we implemented that stop method to set their plane velocities to 0. And we can now kill the timer as well. So if the timer has been set, then what we should do is to kill the timer. And okay, we're going to kill the timer, and we might as well, while we're doing this, we should set the timer value to be equal to 0, so we know we've stopped the game. Okay, let's set that running. We haven't implemented plane release interval. Let's do that now. And let's release a plane every 5,000 milliseconds. Every 5 seconds. Okay. And so now the game should be running. And we should see that a plane has been released. Let's resize our window. Okay, and you notice that a plane is released every 5 seconds, and here we have a potential collision. Now, okay, so what we need to do now is we need to detect when the score is changed, so that we can either implement a win or a lose strategy. So let's go and find our score method. Okay, and we're setting the score into our score presenter, but now let's do a test to see if it's a winning or a losing score. If the new score, for example, is less than 0, we can basically treat that as a loss situation. So let's implement that as you lose. And if the score is greater than some winning value, or equal to our winning score, say, then we can call self you win. Okay, let's run that. And what have we got here? We currently are we're on minus 200. Oh, let's have a look. We need to just stop the game before we have too many collisions. Okay. Game shell does not understand you lose. Let's implement this quickly before we have any more interrupts. So in you lose, we need to do an error beep. Say, this is one of the problems about programming while you're running running the game. Let's compile that so that it actually will stop the game when we get the next signal through. So the other thing we might want to put into the lost portion of the game is some status message. We haven't used the status view yet. So let's set our status to be some value lose, and we can also, let's provide a colour for that as well. Make it a red colour, for example. Okay, let's let that run. ATC Game Shell does not understand status colour. Let's implement that. Okay, I've got a string and a colour. So let's just set the value of the status presented to the string we've got. And now we can go and talk directly to our view, the status presented view. Oops, sorry. And we can set the fore colour of the view to be equal to the colour we've been given. Okay, and now let's let that run. And now you notice we have the status message "you lose" at the top there. Okay, if we set this game running again, ATC Game Shell does not understand winning score. We haven't implemented that method yet, so let's do that. And let's say 2000 is the winning score, and let's let that run. And we should see the planes being released every 5 seconds once again. There we go. Now I don't want to wait until we actually get to the winning score because it could take too long. So what I'm going to do is I'm going to actually implement the you win method directly while it's running in the background. Terminate that. You win. Let's implement that. And what we'll do is we'll do an information beep here. Once again, we'll stop the game, and this time we'll give a status of you win. This time with a colour dark green. Okay, and that should be the game all ready and finally complete, ready to go. So let's just have a quick go. Expand the view. And let's start the game. A score of 0, remember. First flight should be triggered now. And we wait for the next one. Okay, these two flights are obviously going to collide, so let's try and steer this one round. And now I can turn this towards the right to back onto target. I've got another one here which needs to be got out of the way quickly. Unfortunately, we've had a crash before any planes have arrived, so we've got you lose and a -200 and a game over situation. Okay, and I think that's basically all we need for the time being. If you take the downloadable code from the website, then you should be able to see some of the more cosmetic changes I've made to make the game look more appealing. Anyway, I hope you've enjoyed this. Thanks for watching, and enjoy using Dolphin Smalltalk.
Is he turning, James?
No, I haven't clicked on any.
No, they're gonna crash.
No.
No. Oh, they are.
They are.
Yes, they are.
Yeah, they probably are.
Woohoo! Can we make it? Yeah, we made it!
Yeah, and if I look at the ones that's crashed. No. Now put it back on, guy.
Everything looks good to me. Everything looks good to me. Except from that is that.
Oh, did he die?
Yes,
Damn.
they are.
There you go. I should make it.
They are not going to crash. They are not going to crash. They are going to not going to crash.
Yeah, we get a picture. They're going to crash.
No, not that way.
Yes, that way. They might crash.
They're not, James. And even no one's going fast. I'm going to Athens.
Yeah, well, everyone likes Athens.
Go to Madrid. Yeah, I can't see what the plane thinks. They're going to crash.
No.
Yes, they are. Yes, they are. They are. Click on him because it might crash.
No, click on the other one.